The National Electrical Code, or NEC, does allow you to run bare Plenum rated control wiring in an automotive service area with an open ceiling. NEC Section 300.22c3 addresses wiring in ducts, plenums, and other environmental air handling spaces. Specifically, 300.22c3 focuses on equipment other than electrical equipment. It states that the equipment permitted within the environmental air space shall be permitted only if it is identified for such use. This means the equipment must be suitable for the environment, considering factors like temperature and potential exposure to corrosive substances commonly found in automotive service areas. Furthermore, the section details requirements for wiring methods. Only wiring methods suitable for the use and identified for the purpose are permitted. Sections 300.22c3 through D elaborate on acceptable wiring methods. Section 300.22c3 permits totally enclosed, non-ventilated insulated busway having no provisions for plug-in connections. Section 300.22c3 B allows for rigid metal conduit, intermediate metal conduit, or electrical metallic tubing without flexible connections. Section 300.22c3 C addresses flexible metal conduit, liquid-type flexible metal conduit, and flexible metallic tubing, with specific limitations on length. These flexible conduits and tubing must not exceed 6 feet in length. Section 300.22c3 covers liquid-type flexible non-metallic conduit. It is important to understand that these allowances are subject to conditions of use. The NEC mandates that the wiring methods mentioned above must be installed to prevent the entrance of fibers and particles. This requirement is particularly crucial in automotive service areas, where dust, debris, and other contaminants are prevalent. These contaminants could potentially degrade the insulation or cause electrical faults if they infiltrate the wiring system. The section also includes an exception. Equipment is permitted to contain factory-installed wiring within these spaces, provided it complies with 300.22c3. This exception acknowledges that certain equipment may be pre-wired at the factory, and as long as this wiring meets the overall safety standards, it is allowed. It is important to note that while the NEC permits specific wiring methods, local codes and regulations may impose additional restrictions or requirements. Therefore, consulting with local electrical inspectors or authorities having jurisdiction is essential to ensure compliance with all applicable codes. Additionally, understanding the specific requirements of the Plenum rating is crucial. Plenum-rated cables are designed to resist the spread of flames and produce minimal smoke in the event of a fire. This is especially important in enclosed spaces like plenums, where smoke and toxic fumes can quickly spread, posing a significant hazard to occupants. NEC Section 334.30 dictates the requirements for installing non-metallic sheet cable, specifically NM, NMC, and NMS cables. These cables are commonly used in residential and commercial buildings for various wiring applications. The section emphasizes the importance of protecting these cables from physical damage. The first part of 334.30 states that non-metallic sheath cable must be protected from physical damage where it passes through floors, walls, or partitions, or where it is subject to physical damage. This protection can be achieved through various means, such as using conduit guard strips, or other approved methods. The goal is to prevent the cable from being cut, crushed, or otherwise damaged, which could lead to electrical hazards. The NEC provides guidelines on how to properly support non-metallic sheath cables. Cables must be secured by staples, cable ties, straps, or similar fittings designed and installed so as not to damage the cable. Furthermore, the cable must be secured within 12 inches of every box, cabinet, fitting, or other cable termination. This close securing helps to prevent strain on the connections and ensures that the cable remains properly supported throughout its run. The NEC also specifies the maximum spacing between supports for non-metallic sheath cable. Generally, cables must be supported at intervals not exceeding 4 or 1/2 feet. This spacing helps to prevent the cable from sagging or becoming damaged over time. However, there are exceptions to this rule for specific situations. For example, When cables are fished between access points, such as in existing walls, the support requirements may be relaxed. The NEC also addresses the issue of bending non-metallic sheathed cable. Cables must be installed so that they are not bent to a radius smaller than 5 times the diameter of the cable. This requirement is important to prevent damage to the cable's insulation and conductors, which could lead to electrical shorts or other problems. Sharp bends can also create stress points in the cable, making it more susceptible to damage over time. When running non-metallic sheath cable through bored holes in framing members, the NEC provides specific guidelines for protecting the cable. In general, the cable should be located at least 1 1/4 inches back from the nearest edge of the framing member. This helps to prevent the cable from being damaged by nails or screws driven into the framing. If the cable is closer than 1 1/4 inches to the edge, it must be protected by a steel plate or bushing. This protection helps to prevent nails or screws from penetrating the cable and causing electrical hazards. The NEC also addresses the use of non-metallic sheath cable in accessible attics and underfloor spaces. In these areas, a cable must be protected if it is run along the floor or within 7 feet of the floor. This protection can be achieved through the use of running boards, guard strips, or other approved methods. The goal is to prevent the cable from being damaged by foot traffic or other objects in these areas. The NEC allows non-metallic sheathed cable to be run through thermal insulation, but there are specific requirements that must be followed. The cable must be installed so that it is not compressed by the insulation, which could damage the cable's insulation. Additionally, the cable must be rated for the temperature of the insulation. This is important because some types of insulation can generate heat, which could damage the cable if it is not properly rated. The NEC provides guidelines for using non-metallic sheathed cable in damp or wet locations. In these areas, the cable must be listed for use in wet locations. This means that the cable has been tested and approved for use in environments where it is likely to be exposed to moisture. The cable must also be installed in a way that prevents water from entering the cable's insulation. Understanding the ampacity of non-metallic sheath cable is crucial for ensuring the safety of an electrical system. Ampacity refers to the maximum amount of current, measured in amps, that the conductor can safely carry without exceeding its temperature rating. The NEC provides detailed tables and guidelines for determining the ampacity of different types of conductors and cables, taking into account factors such as the conductor's material, size, insulation type, and installation conditions. The ampacity of non-metallic sheathed cable is typically lower than that of conductors installed in conduit due to the cable's insulation and installation method. It is essential to consult the NEC ampacity tables to determine the appropriate size of non-metallic sheath cable for a given circuit. Overloading a cable beyond its ampacity can lead to overheating, insulation damage, and potentially electrical fires. Correctly calculating and selecting the appropriate ampacity for non-metallic sheath cable is paramount for electrical safety and compliance with the NEC. When using non-metallic sheath cable in an automotive service area, it's essential to consider the specific environmental conditions present. These areas often contain flammable liquids, vapors, and dust, which can pose a significant fire or explosion hazard. Therefore, it's crucial to ensure that the wiring installation meets all applicable requirements for hazardous locations, as specified in Article 511 of the NEC. Article 511 classifies automotive service areas as either Class I, Division 1 or Class I, Division 2 locations depending on the likelihood of flammable substances being present. In Class I, Division 1 locations, where ignitable concentrations of flammable gases or vapors are likely to exist under normal operating conditions, only intrinsically safe wiring methods are permitted. This type of wiring is designed to prevent the release of sufficient electrical or thermal energy to ignite flammable substances. In Class I, Division 2 locations, where ignitable concentrations of flammable gases or vapors are less likely to exist, other wiring methods are permitted, but they must be enclosed in rigid metal conduit, intermediate metal conduit, or other approved raceways. Non-metallic sheath cable is generally not permitted in either Class I, Division 1 or Class I, Division 2 locations due to its lack of protection against physical damage and its potential to propagate flames. The NEC also requires that all electrical equipment installed in hazardous locations be specifically listed and labeled for use in those locations. This ensures that the equipment has been tested and certified to meet the stringent safety requirements for hazardous environment. In addition to the requirements for hazardous locations, it's also important to consider the potential for exposure to corrosive substances in automotive service areas. These substances can damage the insulation of non-metallic sheath cable, leading to electrical shorts or other problems. Therefore, it's crucial to select cables that are specifically listed for use in corrosive environments or to provide additional protection for the cables, such as enclosing them in conduit or using corrosion-resistant coatings. The NEC provides detailed guidelines for selecting and installing wiring methods in various types of locations, including automotive service areas. It's essential to consult the NEC and other applicable codes and standards to ensure that the wiring installation meets all safety requirements. It is also critical to consult with a qualified electrical inspector to ensure that the installation is in compliance with all applicable codes and regulations. The inspector can provide guidance on the specific requirements for the location and ensure that the installation is safe and reliable. In addition to the NEC, other codes and standards may also apply to wiring installations in automotive service areas. These may include local building codes, fire codes, and environmental regulations. It's essential to be aware of all applicable requirements and to ensure that the installation complies with all of them. Proper wiring installation in automotive service areas is essential for ensuring the safety of workers and customers and for protecting the facility from fire and explosion hazards. By following the NEC and other applicable codes and standards, and by consulting with qualified professionals, you can ensure that the wiring installation is safe, reliable, and in compliance with all applicable requirements. When selecting and installing wiring in an automotive service area, it's crucial to prioritize safety above all else. The potential for electrical hazards, fire, and explosion is significant in these environments, so it's essential to take all necessary precautions to minimize the risks. This includes selecting the appropriate wiring methods, ensuring proper installation techniques, and adhering to all applicable codes and standards. It's also important to provide regular maintenance and inspections of the wiring system to identify and correct any potential problems before they can lead to serious hazards. By taking a proactive approach to safety, you can help to ensure that the automotive service area is a safe and healthy environment for everyone. While the NEC permits bare conductors in some situations, this permission is often conditional and depends heavily on the specific application and environment. Generally, bare conductors are allowed where they are part of an approved assembly or equipment, or where they are installed in locations that are accessible only to qualified persons. In situations where bare conductors are permitted, it's essential to take extra precautions to protect them from physical damage and to prevent accidental contact. This may involve installing barriers, enclosures, or other protective measures. It's also important to provide clear warning signs to alert personnel to the presence of bare conductors. In some cases, the NEC may require the use of insulated conductors even in locations where bare conductors might otherwise be permitted. This is particularly true in areas where there is a high risk of electrical shock or where the conductors are exposed to moisture or corrosive substances. The decision to use bare or insulated conductors should be based on a careful assessment of the specific application and environment, taking into account all applicable safety requirements. In addition to the requirements of the NEC, other factors may also influence the choice of wiring methods in an automotive service area. These factors may include the cost of materials and installation, the ease of maintenance, and the aesthetic appearance of the installation. However, it's important to remember that safety should always be the top priority, and cost or convenience should never be allowed to compromise safety. In some cases, it may be necessary to invest in more expensive wiring methods or installation techniques to ensure that the installation is safe and reliable. The long-term benefits of a safe and well-maintained wiring system far outweigh the initial costs. Ultimately, the goal of any wiring installation should be to provide a safe and reliable source of electrical power for the intended purpose. By following the NEC and other applicable codes and standards, and by consulting with qualified professionals, you can help to ensure that the wiring installation meets this goal and protects people and property from electrical hazards.